If the axle head breaks into two pieces due to overloading, in this case, 20 tons of extra load, and it cannot be replaced, the repair solution involves welding and reshaping. In this situation, the repair technician needs to reassemble the axle head using a process called stack welding. The broken surface is very even, so the technician opts to build up a weld at the center of the brake to create a protruding point. This protrusion is necessary to facilitate the later alignment through the hole. However, because manual welding cannot achieve perfect centering, the technician must first measure the concentricity of the axle head to ensure that it aligns with the lathe's chuck. This allows the uneven weld to be more precisely shaped into a smooth, round point. To maintain the structural integrity of the repair, the technician uses calipers to measure the outer diameter of the protruding weld repeatedly, ensuring it is centered and concentric. This is critical to prevent any misalignment that could lead to an unstable connection. Once the correct diameter is achieved, the technician shapes the entire outer edge into a beveled edge, as a larger welding area will create a stronger bond. To embed the built-up protrusion into the rear axle's center, the technician secures the heavy axle onto a large lathe using a high-grade hoist and iron chain. The rear axle is leveled using a central support, even though the end surface does not affect the hole drilling for the axle. For a tight, seamless weld between the protruding section and the axle head, any slightly deformed parts must be trimmed to prevent internal defects within the weld. The technician then drills holes in the protruding weld, using its outer diameter and length as a processing benchmark to create consistent, precise holes in the axle. This meticulous process showcases the attention to detail and precision of the repair work done by Pakistani technicians. Although this repair may appear straightforward, every step requires precise measurements and attention to detail. Once the technician uses a caliper to confirm the hole diameter is correct, they proceed to align the axle head with the corresponding hole. Because there is no margin for error in the fit, the technician uses the thrust from the lathe's center punch to slowly push the axle head into place, ensuring the length of the rear axle doesn't shorten during the process. Next, high-hardness welding rods are used to weld the beveled edges together, with a remaining gap compensating for the thickness of the cutting, allowing for additional welding points on the brake. Since the axle head must accommodate a bearing, the rough weld must be shaved down to restore the axle head's original outer diameter. With the help of a high-precision micrometer, the surface of the axle now meets the bearing specifications. This means the semi-trailer's non-powered rear axle is once again ready to haul cargo. The skill and precision involved in such repairs are truly remarkable.